That was a loud bang. Okay, so I'm just going to get things organized right now. All right, so what I need to do is turn off the audio just so I don't have to hear myself in the background. And we're going to get started shortly. I just want to organize a few things. The first is documents, projects, art pack. I got some new artwork from Evie yesterday. So let's go to terminal and git update. So I pull all, and that should give us the furniture. Cool. We'll need to use that. And then the other thing that we did in transfer is I have a new build of Pixel Vision 8, which let's put in documents, Pixel Vision. All right, so yesterday there were a few bugs that we noticed on the when using the Sprite Builder and some other things. So today, hopefully this build is a little bit more stable. Let's boot this guy up and get this going. And I'm just gonna get everything organized, and then we'll get started with the stream. We got a lot of pixel art stuff to do today, which I'm excited about. And let's open up resources, our Sprite PSD, and we'll get that going. Let's get Pixel Vision 8 running as well. I should actually, while we're doing this, let's see if we can, I want to file a bug just so I remember to do this. Whoops. Well, I fixed all these. One thing I want to do is standalone builds run in background. I think it's kind of important that the standalone builds need to compile game creator to run in the background to help with debugging. So we should have, one thing I don't have Pixel Vision 8 do is run in the background, and I sort of want to fix that. So we'll add that to the list of things that I can do when I do the next build, which should be out hopefully on Friday. If you're just joining in, today we're going to do some Pixel Vision 8 game dev, which is, Pixel Vision 8 is it's an open source C# framework that I wrote, and there's a standalone game creator that uses Lua that sits on top of it. And yesterday we were building out these sprites. I think it's going to get, unfortunately, there's going to be a little bit of a hum in the background. It's a laundry day at the Freeman home. So since my office is right outside of where the washer and dryer is, that's going to be annoying. Hey, Diddy Game Boy, welcome to the stream. So while the wash winds itself down, I'm going to just do some housekeeping stuff. We'll start up Pomodoro timer, and again, if you hear the background noise, I'm sorry, but hopefully I'll make it up to you with some really cool pixel art stuff that we're going to be doing, and getting things, make it a pretty good game. So what I'm going to do first, so this is what we did yesterday, is we took Evie's pixel art. So if you weren't watching yesterday, let's see here, Twitter. So Evie is the pixel artist for this little game demo that I'm working on, and I wanted to create a little demo for how to build sort of like a Nintendo style game inside of Pixel Vision 8. What I did was I hired him to do take an old game of mine, which is my Super Zombie Runner, and just convert it into like a NES style sprite. So Evie did the artwork that we're going to be working with, and I think it came out pretty good. I actually really like. We were playing around with getting just the basic animation and stuff. So this is an example. The guy on the left and the guy in the middle are the same characters. I'm just doing some palette swapping. We have a zombie on the right, and we're going to turn this guy into like a very basic little Nintendo game. So what we need to do is we need to clean up this this sprite sheet. But the other thing that I wanted to do was I want to bring in the new artwork. So we're going to get started with that, and I'm just going to build a few tasks for the things that I want to do today. So add in furniture. I can't spell. I guess we're going to be like furniture, right? I spelled it right there, but then I didn't spell it right in the task itself. Furniture. Add in furniture. So we want to generate out Sprite Builder file, which we should be able to do today. We were creating palettes yesterday. We're going to add in the furniture, and we're going to optimize artwork. All right, so all this stuff should now work. I spent some time last night fixing some bugs, and the cool thing is that, like I said, there's going to be I'm releasing this next build on Friday, and it's pretty stable now. I mean, outside of like I refactored a ton of stuff. A ton of stuff under the hood. So now what we're doing is I've just been going through, and while I build out some games, I've just been sort of trying to get just trying to make sure that all the bugs are out of it. And this is, I wrote Pixel Vision 8 for myself. Obviously there's an open source version of it. There's a paid version if you want to use like some of the pro tools and the stuff that I've like hired other people to do. So I try to support the developer community as much as possible, and part of the work I've been doing at Pixel Vision 8 is to hire some like the best indie artists and coders that I know and have them sort of involved in the project. And so that's the only thing I charge for is just for it to pay for itself. But really, this is a tool for me to build the games that I like. And one of the things that we're doing at Amazon, and sort of why I'm going to start building up more games in the stream, is this notion of like casual esports and these services that we're fighting for these services that we're doing for game developers to be able to run contests and promotions and get audiences playing their games. Let's see, Digi Game Boy would say, I didn't find Pixel Vision intuitive, but I blame myself. This game example will help a lot. Yeah, the early versions of Pixel Vision 8 aren't particularly intuitive. I've been spending a lot of time on cleaning up the UX and making it clearer. It definitely doesn't work like other fantasy consoles. It looks similar to other fantasy consoles, but the workflow is like really completely different. And if you're not familiar with what a fantasy console is, this is basically a constrained hardware platform. The difference between Pixel Vision 8 and sort of the other fantasy consoles out there like Pico 8 or TIC 80, I believe, TIC computer, is that Pixel Vision 8 is very customizable. Like, so each of these different platforms allow you to change the resolution, the amount of colors per sprite, all that kind of stuff. Now the new builds have a lot more demos, so I just added some new demos for drawing with a canvas. There's all different kinds of tools, and there's a new drawing API that you can use. So that gives you an example of how the canvases. There's tutorials for the controllers, so you can use controllers. I've been going through and redoing the way that the drawing system works. So here are some examples of how the draw sprites work. And all of these, you can just simply go through, click edit, and then just see all the source code for all these demos. Added back in some stuff to show you how to do wrapping of sprites. So on the original Nintendo, because of the way the memory worked, if you actually changed the X position over 256 pixels, it would wrap around to the other side of the screen. So this sort of shows you how to use that wrapping to your advantage. What else is there? There's a whole new font rendering API. So you could do pixel fonts, which are pretty straightforward and easy to use. There's even some demos here from on how to do just basically a simple platformer, and that's using like a Pico 8 example that that was converted over by Matt. I forgot what Matt's last name is, but we can it's all the source codes in there. I'm also, for the pro users, I've included the full source code to my last game that I wrote in Pixel Vision 8, which is Reaper Boy. So this is something that Cass Pixel and I had worked on for Ludum Dare, and this is just a full game that sort of shows you all of the APIs, how to use them, how things sort of work, and give you some examples. The code isn't the cleanest because it came from a game jam, but I am working on sort of cleaning it up. And then there's other stuff in here that's helpful, like how to do the tile maps. So this shows you like how to do split screens if you want to do a HUD at the top and then do some sort of stuff at the bottom, and then it's hard to see, but the ocean on the left and the right hand side is all palette swapping. So this shows you an example of how to do like pretty accurate Game Boy style artwork, and it's at a Game Boy resolution. So, and I can't think if there's any other. There is a new demo that I added that I got from someone on Twitter who is doing these sort of really cool tweet carts. Oops, that's not it. That's the Sprite block. There's some like drawing APIs now that you could do for generative art. Unfortunately, this demo doesn't run very fast right now. I need to go back through. There's something with the Lua interpreter that just basically it runs like really tight for loops, really slow. So I need to just go through and just retweak the way that this works. If you did this in C# though, and that's one of the differences between Pixel Vision 8 and the other competition, or not really competition, but the other fantasy frameworks, is that if you you could also build this stuff in C# and not do it in Lua, and you get like native performance. So I think the laundry is done, so I can stop self-promoting. And then also there's a whole bunch of plugins and built-in stuff. So what we're looking into doing today is we're going to clean up these sprites and everything. We're going to optimize all this sprite stuff. We're going to get palettes working, and we're going to add in the furniture. And I just want to start, let's just dive right in, and we're going to go into Photoshop. And actually, before I do that, I'm going to need to take a little drink. My water bottle is sort of noisy, so sorry. There, I figured I'd be polite and muted. I'm like super OCD in my office about not having open containers, so I usually just use like my bike workout sort of water cup. So okay, so here is our furniture that Evie created, and we're just going to add this into our sprite sheet. So the way I set up Photoshop here is that I have a grid that it's basically a 16 by 16 grid with a subdivision of 2, which gives us 8 by 8 tiles inside of it. And so what happens is you can see that these guys, they're fairly large for Nintendo size stuff. Ooh, didn't want to burp in front of everyone, although probably talking about it is just as rude. So these characters are all 3 sprites across by 4 sprites down. And one of the things we got to figure out is that this is pretty big for Nintendo style sprites. And what we got to do is figure out how they're going to fit in the background, and because the resolution on Nintendo is pretty high, ironically enough. Actually, wait, I wanted to go here. So you see, they look a little tiny in this whole screen. So we're gonna have to come up with some interesting background stuff. And what I want to do in this demo is play around a lot with parallax scrolling and HUDs, and sort of show off how the Nintendo actually had a very small render area, and it used that render area to like sort of feed in tiles at runtime. So we're going to do some pretty interesting generative level creation as time goes on. But that's right now the real focus is just getting the artwork cleaned up and having this stuff sort of ready to go for when we get the backgrounds done. So I'm going to set these sprites up, and what I was doing yesterday was I'm just going to do, in the layer, I'm going to do a green background, and we're going to copy over this sprite. Now I'm a little bit confused. Why is this guy 16 by 18? I think what I'm going to have to do is I'm probably just going to crop this. I don't think we need the top part of the TV. That's just a little... All right, we're going to take a look at the furniture, because I didn't really work with Evie on how I wanted to spec out the furniture, because I think in the last one it worked at a very specific height setting, so that when you jump on them they work correctly. So what we'll do is we're going to take a look. We're going to copy over all this furniture, and we're just going to make sure that it's sized correctly. So like this stuff here needs to be 16 by 24, and let's just bottom left align it. Yeah. So all right, we'll clean that up. I'll just copy it over, and then we'll clean it up from there. So one of the reasons why it's important this stuff is at a very specific height is that we're going to do some very simple math in order to get this stuff working. And what we want to make sure is that the player is always at the top part, or that they all are at the same height, so that when the player jumps, we can just make sure that they're always going at the same place. Digi Game Boy, how do you choose a transparent color, or do you let a transparent canvas? So for Pixel Vision 8, the default transparent color is this magenta here, which is FF00FF. So now in the system, what I can actually do is, let me open up the workspace. So Pixel Vision 8 is sort of unique. It creates a dedicated workspace. And so when you're in the file picker, you can choose the workspace, you can copy out the path, and assuming that we weren't actually there, we could just, whoops, what is it? It's this. We can navigate directly to this on our computer, and you'll see here that in the game creator folder, it's automatic. I have a 0.8.8 alpha, which is the new version, and it creates a workspace in there. Inside of the workspace are all the folders that Pixel Vision 8 uses. So technically, if you went up to the root directory, you'll see a lot of these folders are in here. And the sandbox folder is where we work on games. So all the stuff that we're doing is going to be in the sandbox folder, and when we're done, we save them and they go into the games folder. So the question really was, how do we choose the magenta, or how do we choose the transparent color? And in the new build of Pixel Vision 8, what's going to happen is, if you take a look at, I just opened up the data file. The data file defines all the settings for the game. Inside of the color chip is a new property called mask color. This was always there, I just didn't really expose it. And you can choose what you want the mask color to be, but by default, it's always going to be FF00FF. If you did transparent, it'll still work fine, but technically Pixel Vision 8 doesn't understand what transparent is. All it knows is that when it's rendering, if it sees a color like this, it's going to ignore it and, in essence, make it transparent. So let's go through and... whoops, I didn't want to do that. I closed the wrong one. What did I miss? Documents, projects, art packs, Nest, zombie, animation, furniture. I think I closed this, number 2. All right, so I can't see the edge of my screen because my phone is covering it. So let's move that out of the way. So, all right, so we're gonna copy this piece of furniture over next. All right, so yeah, so there's, they're not lining up correctly. So, but that's fine. This will just be 32 by 16. We'll bottom align it. Let's just fix that background layer, and we'll copy this guy over and delete this. I'm not going through the keyboard shortcuts. I've been using Photoshop for, I don't know, since version 1. So I sort of like just instinctually use the shortcuts. But if you have questions or you want to understand a little bit more about Photoshop, I can try to be more, I can try to be better at it. Like I'm using Apple Option C in order to get the canvas size. And I'm going to set this to 32. We're going to set this height to 16. And we'll bottom left align it here. And then I'll create a new layer, move this layer down, and then I'm going to hit it's Option Delete on the Mac. I have a PC keyboard on a Mac, so you figure that one out. And then when you have 2 layers like this, you can actually copy all of it together and merge it by holding down the Apple Shift C key. And then if you paste it, you'll have everything sort of matched up. And the reason why I'm doing this is I want I'm adding the green so I can just make sure that whenever you copy something, if it's transparent, it's not going to copy it at the correct size. It sort of automatically crops it. Here, I'll copy the right thing now. So if I pasted this down, you'll see it's transparent, and I have no way of sort of knowing where to put it. This isn't so bad for the furniture because it's easy to align, but other stuff like the animations needed to be put at a very specific place. So I just use this green masking as a way to understand where things are going. Let's see here. This is 16. Well, at least he's consistent with the sizing, so it's not the end of the world. I hear the the washing machine spinning up again. It's like recording in an airplane hangar. Let's go to canvas. So hopefully we'll get rid of a lot of this monotonous stuff that I need to set up right now for the artwork, and then when the washing machine is done, I can go into the cooler stuff. I don't have a lot of time. I got to end at 11:30 today, so we'll see how far we get. But the goal is that this week, I just want to I want to get as much of the foundation of the game up and running as possible, and see if we can do like a little tutorial on how to do it. Because eventually, what it's going to do is I'm going to turn this game into a Nintendo style casual esports title. And it's basically just going to be a competitive runner where other people have to run against each other, compete against the time, and see how they do with other people. And then we'll do some cool real world prizes, and we'll be using one of Amazon's new services, Game On, in order to do that. So hopefully in the next week or two, we'll have enough of the game up and running that we can sort of add that in. All right, so we got the furniture. We got the furniture set up, and I think this stuff looks really good. What I want to do is come in and see if there's a way that we can stretch this out a little. Although if they all end, yeah, like this right here, I want all the furniture to sit. Well, I don't think this is going to be too much. I think this guy is fine because he's going to be half the height, and then these are all full height. I think, given the way that he created the furniture, what we'll do is we'll just all treat them at the same height. They all seem to be ending with 1 pixel from the top, so that's good. I think the only thing that's bothering me with the couch is that this part here. I'm just trying to figure out how I want to treat this. So what I'm trying to figure out right now is, well, maybe we'll just do the couch as half height. Basically, since I need to be able to quickly calculate the box area of these items when the player is jumping over them, what I want to do is make sure that they all adhere to a very specific size. And okay, let's get started here. Like, I want them all to sort of stretch out to the end of the, whoops, wrong key. I want them all to stretch out to the end of their bounding area so that we always have them at the same width or at a full tile width. So something like this is going to be a little bit more complicated because it's even in the middle, so you're going to see the seam. So like if we copied this guy here and we moved it over 1, I don't like that much. There's no center. All right, so you know what? I see why is this not going back? There we go. I see why he did this. The couch is a challenge because this well, I guess what we can do is we can just center the couch in this area. So let's, oh no, washing machine, shut up. Sorry about the washing machine. Well, later this week, my wife's actually going to be out of town, so there won't be that stuff going on. I think she's just getting ready for her trip. So I'm not going to tell her no. So, all right, so we basically have this stuff. All right, this stuff is consistently aligned. I'm sort of happy with it. It'll be fine. And now that we have all this furniture sort of together, what we can just do is let's merge these layers together into a single layer. Then I'm going to delete the green mask color, and we'll just leave it'll be transparent, but when it outputs, it'll do magenta. And the other thing that we're going to do, and what we were doing in Pixel, what we were doing yesterday for Pixel Vision A, is that we were cutting out the shapes, and we're using Photoshop's slice tool. So I'm just going to set this up as let's just spell this right. Yeah, furniture. Yeah, I really can't spell. It's fascinating. Furniture, TV, what, I don't even know like what I want to. Dresser. Is that a dresser? I guess. Yeah, I guess it's a dresser, right? We'll do like we'll do furniture. Whoops, furniture dresser. Small. We'll do furniture dresser large. I think that spin means it's like finally almost done with the wash. I don't know why that washer is so loud. So, again, if you're just tuning in, I'm doing pixel art while the laundry's going on in the next room. Always the professional, Jesse. Always. This is a couch. Why can't I spell today? Oh my god. There we go. Just making sure there's no silent E at the end of the couch. English is my first language, unfortunately. Table. And what we should do is, actually, this should be the small one. Medium and large. So, and then there's something about my OCD that requires me to possibly move these things around. So let's just put them in the right order. I'll have to switch the so these two go here. This goes here. And let's move this stuff over to here. And move this here. So this is like early on in game development, you wind up doing a lot of this kind of stuff, which is just a lot of production work. So once this production work stuff is done, it's... I mean, I like to do as much of this up front, get everything cleaned up, organized, know what I'm doing, because then making the game is a lot more fun, because then I don't have to worry about any of the artwork stuff. All right, so these slices will now represent the furniture that we're doing. And wow, I turned on my volume preview, and I can hear the woo 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 in the background. All right, so let's do this. Before we move on, I just want to save this as Sprites originals. And what we're going to do is we're going to finish up the palette work that we sort of did before. Now, I think well, there's two things we could do. I think the first thing is I want to actually save this project. So let's go in here. And I just want to save a version of it. We're gonna, whoops, I had the wrong place. Excuse me. Let's see here, data. So we're gonna call this NES Zombie Runner V1, and we'll hit save. We're gonna quit, and then we're gonna press archive. So what archive does is it copies all the contents of this folder. Whoops, what we should have done is let's save this PNG. And we'll refresh it and we'll re-archive it. It'll just override to the other one. So we're going to save all these files, and now in our game folder, we should see a NES Zombie Runner V1. And the only reason I'm doing that is because we're gonna break a few things, and I'll wait for the washer and the washer to stop before I get into like the really good stuff that I possibly want to actually save the audio from. But that being said, what we're going to do now is we sort of saved out a version of this. I want to make a new version that has all the palette stuff. In this NES Hell grid. Well, I'll walk you through how I did it yesterday. So the animation stuff is actually... So there's a few things I did in this build of the game. So yesterday we ran some bugs with the Sprite Builder, and I'm going to show off how the Sprite Builder works today. Actually, let me just end this Pomodoro, and I'll walk through how we did. So we added the furniture, done, and we'll just leave it at that. Okay, so one of the things we did is we went into the data file and we went into the sprite chip and we modified the unique setting to false. And now if we set this to true, which is what it is by default, Pixel Vision 8 is automatically going to optimize the art and remove any duplicates, remove any transparent, and you see you get this like jumbled mess of sprites, but you can see that everything is actually compressed down to like basically one page. If we set this to false, which is what we had it at yesterday, it's going to import the sprite sheet exactly how it's loaded up. And you see now the sprites are taking up 2 whole pages, but they're a little bit easier to work with. And what we're using is we're using a new API called Draw Sprite Block. And what Draw Sprite Block is, it's very similar to Pico 8, where you simply define the upper left-hand corner, and then you give it the width and the height of sprites, and it'll cut out a block from sprite memory. And the reason why turning off unique is important is that you want the sprite sheet to match up here with what you're expecting. Now, if we look at the code, we created a little entity class here, and I'll show you this. So what we did was we created a set of APIs that create like an entity object. So we just create a table, and the table stores some stuff, and we can build on it. So like here, when we create an animated entity, it uses the previous entity data, and then it adds some animation stuff to it. And when we get into this create guy animation, what we're doing is we're defining the upper left-hand corner for each of the sets of animations. So this is 0, 3, 6, and 9, which make up the idle. And here you see is 0, 3, 6, and 9. So when we play back the animation, the guy in the upper left-hand corner is just going through, copying those tiles from memory, and then basically drawing them to the display. So here you can see we have draw sprite block. We get the start sprite ID, which is the upper left-hand corner, the X and Y position, the width and height, which is in sprites. So the width and height is going to be 3 by, I can't remember where I defined it. Somewhere around here I defined it. I did it here when I set up create the guy entity. It's over here. So the width is 3 sprites and the height is 4 sprites. And then there's some other properties here, such as this is a horizontal flip. So if we made this true and we refreshed, you would see the guy is now facing the left-hand side. If we did true here, this is vertical flip. So you'll see he just flips upside down. Draw mode is where we want, is the layer we basically want it to draw to. So there's a lot of different draw modes, sprite being the most obvious. There's also a sprite behind, or sprite below, which is behind the background layer. You can draw to the background layer. You can draw to the UI layer if you wanted to sit on top of everything. And then there's a sprite above, which draws on top of the UI layer. And then there's stuff like color offset, which is what we're using to do the palette shifting, the palette swapping. And then there's some other properties here, which is unique, that allow you to keep the guy on the screen, and some other stuff to take into account, like screen scroll. So if you wanted to just draw the sprite and not have to deal with recalculating where he should be based on the position of the screen scroll, you can use this stuff as a helper. So these are just higher level helper functions to draw sprites. And for the most part, it's pretty straightforward to do this stuff. Once you understand the system, it helps. So what I want to do is we're going to go in and we're going to update this to do palette swapping. And that's what we had set up yesterday. So we're going to take a look at the actual sprites that we built yesterday, and we're going to take a look at the difference here between them and what we were using currently. So what you're going to see here is at the the top level sprites here, they're very 90s colors. And what we did was, instead of just using the regular system colors for a Nintendo, here I'm going to open up, I'll open up the two colors so I can sort of walk through what's going on here. So by default, oh, actually what we should do is, I'm going to close that out real quick. I did fix a bug yesterday. I just wanted to make it a little easier to visualize what we're doing with the palette swapping. I need to just make a change, and then we'll clear this color out. Clear color and save it out. What I want to do is I wanted to save the color sprite, the color PNG, so that it matches the dimensions of each color page here. So as you'll see now, if I reopen the colors PNG, it's now 8 across, just like it is in the preview window. And why this is important is I've broken up the system colors into, these are the default colors of a Nintendo. So this is basically what the Nintendo can render. There's a few colors that are very similar to each other. There's actually a lot of like black space. So the Nintendo had, I think, space for 64 colors, but it only could actually render out like 55 of them. The second page are palettes. And what I've been going through and doing is creating palettes of 8 colors. Now this isn't 100% accurate to the Nintendo. The way that the palette system works in Pixelvision 8 is a lot different than any other game console. I've tried to simplify it. So it's a little hard to wrap your head around at first, but once you get it, it's a little bit simpler than working with 4 color palettes. And in essence, what's happening here is that we have 2 sets of color palettes, which you'll see here. The guy on the left has the green shirt, the guy on the right has the red shirt. And all we did was, you'll see here's the green for the shirt. We just we do the similar colors here and replace it with red. So we're going to create some more palettes here for the rest of for the rest of the players and the furniture. But the trick is we have to use a special color map, and the color map allows you to actually match up colors. So let's get these are the same sizes here. So the color map, wherever a color sits here, if it finds it when it's parsing it in the sprite sheet, it's going to put it at the same position in the color PNG. So what that means is, let's take a look at this right here. These colors are not present on the Nintendo. They are unique to a color palette that I've set up. This is a default color palette. Now what happens is that our sprites are going to be mapped to this color, but when it loads it in, it's going to automatically set it to the first row of our palette. And you can see, so wherever it finds this red, it's going to become this brown. If we were to tell the sprite, shift your colors by 8, it would go, okay, any color that's in the first position, go 1, 2, 3, 4, 5, 6, 7, 8, and the color will become this light brown. And this is sort of how the paletting system works. So what we need to do now is, 1, copy over these sprites to our PSD, and then we're going to recolor these people. So let's see if we can do this rather quickly. So I've already done this guy. So let's copy out the first frames of animation, and we're going to call this default sprites, and let's merge this together into, oops, I lost that. Default sprites. Default sprites, and then we're going to paste in this this new layer, and let's get rid of well, I need some of this here. Let's see here. Let's get rid of the transparency so we can see where we're lining this up. And I'm just going to copy these guys over by hand because the size was a little bit different. One of the things, if you're turning off the sprite optimization, you want to make sure that your sprite sheet is actually 128 wide so that it matches up better with the memory. So we got that. We got these 3 guys. Since we're going to turn that off and we're going to do our own thing, this doesn't have to match up with the sprite memory dimensions at all. Fortunately, there's a lot going on in Pixelvision 8 and any of these sort of 8-bit systems, but there's a very unique workflow to Pixelvision 8, which which is Digi Game Boy sort of pointed out. I agree 100%. It's not intuitive. It takes a lot of time to sort of wrap your head around how this system works. So I'm gonna try to get better at that. So let's see here. So what we got now is we've got all of these sprites. I'm gonna hit W for the magic wand. We're gonna remove the transparency, and now when we go to export this, we're gonna get the new color palette guys. Now the next thing that we want to do, and in fact, let's do a background layer, and let's lock this layer. So the next we're going to do is we're going to palletize the female character here, and the way that we're going to do that is we're going to create a new palette for her, and let's do this here, and we're going to take one of these sprites here. Sorry, just give me, what was 188 height and width? Sorry, I'm not following the question. I was off in my own head. All right, so I wait for him to respond. What we're gonna do is I just copied this person out. I moved it over to a new file, and if we did save for web, which is Command Option Shift S, and we change this to a GIF. No dither, it's going to give us our palette, and I'm just going to take a quick little screenshot of that, and we're going to open that up, and we're going to use it to create a new palette. So let's close this out, and I did this yesterday, and I noticed that there was some issues with the way that it actually, what we need to do first is let's copy out all the sprites here, and let's paste them back in, and we're going to use this separate layer as our layer for doing the palette swapping. So okay, so now I'm going to copy over this palette here. I'm going to paste this up here, and we're just going to create a really quick palette. The other thing I want to do is take the color map palette, and we're going to paste this in here as well. I don't know where that went. It's very tiny. Oh, there it is. I see it. So let's just move this somewhere where we can see it. And what we need to do is the other thing is we got to match up these colors, because when you take a screenshot, it's a different color space, so the colors aren't exactly the same. But it shouldn't be too hard for us to match this up. We're gonna take this blue, and we'll put that there. This gray here, this dark gray here, the brown in the strap goes here, the gold goes here, the purple in the shirt goes here. That's funny, those purples almost match up. The skin color will go here. And what was the other? It was the black. Oops. Photoshop's doing one of its famous, it doesn't like to draw on a pixel moments. So let's see if we can zoom in and get that to work. Ooh, I need to fix the, I need to fix this. This should be a, where the hell do I brush pencil? There we go. Okay. So, so that's the general palette. It's a little different than the guy. So I just want to take a few moments to sort of try to clean this up a little bit. I wish I'd saved how I did the guy stuff. What we can just do is, let's just do this. We're gonna try to follow it on how the guy is set up, and instead of doing this sort of palette thing, I'm just gonna go straight here, and what we're gonna do is we're gonna copy. We're just gonna try to match it up area by area to what the guy has, instead of doing it this more convoluted way. So let me, let's get rid of these palettes, and we'll just do it the old-fashioned way. Okay, so what we're going to do is let's use the magic wand. We're going to select this right foot. We're going to hit I for the eyedropper, and we're going to replace all that with the green. We'll replace the left foot with this red. We'll replace the right leg with this yellow. And we'll replace the shirt with purple. The strap with red. Oh, you know what? That isn't going to work. That isn't going to work as well, but we're gonna have to keep track of it this way. Okay, so the problem is that the female character has a few more colors than the guy. So what we're gonna do is let's just try to match up these colors as best we can. And then I'll go through and whatever the remaining colors are, we'll sort out. Whereas this red was blue. This strap was red. The hands and the face are already done. The blue is already done. The red is already done. The purple is already done. The yellow is already done. This is going to be... so what I want to do is I can't use yellow. So let's do green. Oh, actually there was a... no, we could do this green. Or not. So the guy's pants and his... I don't like that actually. Maybe we might have to fix the guy. Because I like the idea that the pants are a separate color than the hair, which is what the female character is doing. So let's do this. Let's all right. Let's just get them matched up. This is the hardest part. Is really just figuring out a way to palletize them, and then once you figure that out, so like wherever these things are similar colors, we're going to have to split them up. So right now, let's do green for the foot, and then this foot we're gonna have to pick a different color, and I think I'm just gonna go with we have orange, we have purple, we have blue. Let's do this brown color, or actually yeah, we're gonna do this white color here, and then what we need to figure out now is the hair. So what I want to do is, yeah, let's merge these two layers together. And now let's try to clean this up. So what I was trying to get is that every part of the character is actually a unique color. And what we're going to do is we're going to remask out all of the leg area, so that we just have the hair alone, and we're going to give it a unique color. And let's go and do this the same for the player here, or for the guy. So now if I zoom out, we should only have the hair selected. If I delete it, that's just the hair color. And let's go into the palette, and we're going to select, what color haven't we used yet? I don't think we've used this. Well, we used that white. We haven't used this brown. So let's use this brown. So now the hair is a different color than the pants. And the next thing we need to do on the guy is let's take just the foot area from the guy, and we're going to mask that off So we'll remove the strap. This way we can have the strap as a different color. I just want to have the foot. And we'll use this white. All right, so now what I just want to make sure is that every color is unique. So if we do this, so now I'm just going through and selecting each of the colors just to make sure that they are there. And we're getting a full selection here. We're getting a full selection here, and it looks like there aren't any missing colors right now. So that at least allows us to realign both of the players. And one of the reasons why I did it this way is that the male and the female character, their color space should be very similar so that we can use the same palette swapping. It would be silly to have like a different palette swap for the female character than for the guy. So what we're going to do is we're just going to make sure that they're the same. And then we can create like 4 or 6 of these that are unique to either of the players and then swap them out. The next thing that we want to do is I'm going to recolor the zombie, and let's see if we can actually match up the zombie pretty close to what the player's color space is too. There's a few things I'm looking at that I'm probably going to want to change, but I think a lot of this has to do with the reality is a lot of this has to do with the color limitations of the Nintendo. It was only allowed to display 3 colors per sprite. One of the colors is for transparency. So even though, and this is where the disconnect is, right? Like you can choose in Pixel Vision 8 how much you want to adhere to the original system specs, or you can sort of like do your own hybrid. These older systems are incredibly challenging to work with. So one of the things that I didn't want to do is I didn't want to like force you into having to use those constraints. So we're gonna just pick and choose some of the constraints that are easier to work with, and let's go ahead and we're gonna recolor this. So we're gonna take. So what I want to do is I want to break out the different colors. We'll do the skin first, which is the easiest. We're going to make this orange, which will just match the player. We'll do the outlines, which will match the player as well. And then this shirt area, I'm going to mask this off. So we'll just select the shirt area. Evie did a great job at making sure that like the legs are at the bottom, like that everything is broken up very evenly. Like the legs are always this one tile high or one sprite high. So that's going to help out a lot later on if I wanted to like mix and match body parts. Because it looks like he's reusing the running of the player with the zombie, which is incredibly clever because Pixel Vision 8 will see that and it'll cut out those sprites and then we can reuse them. Wherever as much of it's matched up as possible. All right, so we got this shirt here. Let's use this blue. Then we have a leg. So the leg is skin color. I'm going to leave that the same. What I want to do though is pick up on this highlight here, and it looks like this highlight is carried all the way through. But what I'm kind of interested in doing is seeing if we can break out these highlights a little bit better so that we can have a different definition. And I'll sort of explain what that means. So let's go through, let's mask this off, and let's just make the left foot yellow. And what we're going to do is, now I was just thinking I might have screwed this up. I think I'm not sure if I might be adding too many colors. We're going to find out. So that's sort of what this whole process is about. Is one, I'm trying to figure out how this system works and how I can make it better by actually using it. So let's let's just go all around and let's sort of break out each of the colors. So I wanted the hair to be separate on the zombie. That one goes down a little bit, so let's make sure that we just capture the hair. And we'll make the hair brown. And then I wanted to get the eye separate from the mouth, but that might be too many colors. So let's we'll just keep this highlight the same, and we're going to make this highlight red. All right, so that looks like our zombie. Let's make sure that all the colors are correct. Oh wait, I need to merge this and this together. Oops. And that should include the palette layer, right? I wonder what this is. What is this? All right, well, I don't know what you are, so we're deleting you. And all right, so the only thing I just want to check is if we select all the colors on the zombie, that they all match up to a palette. Come on. Photoshop, you're like so terrible when it comes to selecting an individual pixel. All right, so there's one color that's missing. It's this green, I think. Because that's not a palette color. We're going to change it to this yellow. And now every color we choose here should match up to a palette. 2, 3, 4, 5, 6, 7, 8. So that's 8 colors. Okay, cool. So on the original Nintendo, like I said, there's a limit for how many colors you can have per sprite. So an 8x8 area is a single sprite, and you're only allowed 3 colors, with one color being the transparent or the background. And when you go to draw sprites in the Nintendo, and even in Pixel Vision 8, you could define each area would have a certain palette, or each sprite would have a certain palette. Because we're using some of the simpler to use APIs, we're just going to give all of the sprites in this group one palette, which is why I'm sort of cheating and making the palette 8 colors. All right, so let's do this. Let's save this real quick. And what I need to do is, I think I need to do some color correction here real quick. And by that, I mean, let's just copy out. It's no, the Game Boy. It's a palette is 4 colors, and the first color is always the transparent color. So I've done a lot of research on it. Not to be like I know better than you, but that's sort of where it stands. All right, let's do this. We're gonna try to recolor. We're going to create some new palettes and just recolor this because I've changed around the colors. And we're going to do this by eye, which is always an invitation to screw up. So I'm going to do the palette on here first, and then I'll copy it over. So what we're doing is we're going to match up this palette, these default palette colors, to what's actually here in the colors. So we're going to start with this black, which is this purple here. Okay, there we go. It's like, why is it not drawing? All right, then this blue is going to go to the brown. This skin color is going to go to the orange. This green is going to go to the blue. This brown is going to go to the red. We already got the skin color. We have to... Oh yeah, okay, so, right, so this light color here is going to be the brown again. This blue is going to be the yellow, and this light brown is going to be the green. All right, so that's all the colors for the for the guy, let's bring over the woman here, and we will copy this out and paste it. That's still the guy. Okay, let's go to the woman, and we'll copy this out. Hey, my life is hard mode. Welcome. Did you, Game Boy? I'm glad you believe me. As soon as I was saying, I'm like, God, he's coming off like a complete tool. Like, I know everything about the Nintendo, but I spent a lot of time reading through the white papers and how everything sort of worked on the Nintendo in order to get these systems to work. So yeah, I'm gonna say I know it all. All right, so let's go. We're gonna do same thing here. The black is going to match up with the purple. The oops, I can just hold down Option. The gold color is going to match up with the brown. The skin color is going to be consistent. So, and this is sort of helpful. Like as we remap the palettes, what's going to happen is Krita? I don't know what that is. But it's going good. We're doing we're taking some sprites that are designed for Nintendo, and we're sort of building out some palettes for them right now. In fact, it's let me check off my Pomodoro for the last 30 minutes. Creating palettes, which is what we're at right now. All right, so let's see here. This purple is going to go to blue. We've already done the skin color. The pant color is going to be the same. The green is going to gray. The light tan is going to this dark gray. And I'm missing a color, this brown strap. Okay, so this is the woman character. So let's go ahead and delete that. And oh yeah, it's Photoshop. It's okay. I'm officially getting old, so I don't know all the new hipster terms. So when someone says something and I don't understand it, I just pretend like I don't understand it. All right, let's get this guy out, and we'll remap his colors as well. So black is going to, and you'll see Evie did a really great job in this. Like the color spaces match up very nicely with each other. So there's not like a lot of extra work that I need to do here. This brown is going to be orange. The most complicated part is that really I just I broke out the colors a little bit more so we'd have a little bit more control over it. And I think like this sprite here, we're probably not going to be able to do because it looks like there's 1, 2, 3, there's 4 colors here, and that might not actually work. So with Pixel Vision, we don't need to have the exact NES colors. No, all you need to do in Pixel Vision is whatever the colors PNG file is the index for when it parses the colors. So if you don't like these Nintendo colors, you can actually go ahead and change them. And in fact, for the Game Boy ones, I have one of the demos actually uses like closer to accurate, like that nasty green for the Game Boy. But I remapped that for my Reaper Boy game, and we're using a much nicer looking color. Let's do this orange here. So now where this red is, we're going to make this orange. So this way it'll just match up. So I'm probably going to have to go back in and clean up these sprites. Yeah, so basically, if you think about it this way, here's the way the parser works, right? When Pixel Vision 8 loads up, it reads your data file, which has all the settings for what the system is supposed to act like and the constraints. Then it goes through and it reads the color list. Whatever colors it uses, whatever it sees in this list, it builds an index. So this color is 0, 1, 2, 3, 4, blah, 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 all the way to 64 and then to 128, right? When it goes through and looks at the sprites, it goes here and it reads every single color and it says, oh, does this color exist? oh yes, it does. It's this ID, and then it turns these into like a char map, which is just a table of IDs. And then when the renderer goes through, it just renders up the colors. So if your sprites don't have the exact same colors as the colors PNG, you won't see your sprites. But you can make whatever colors you want. And in fact, the tool has, it does let you go in and you can sit here and you can customize these colors however you want. So it's completely up to you, and then you could save it out, or you could just do it in Photoshop like I'm doing today. So where were we? This yellow is going to be here. This green is going to be here, and this is going to be here. And I guess we weren't even using the blue. So, all right, we'll just make, I don't know. We're not using that blue. So how do I want to do that? We'll just make it black since we're not using it. Like the reptile part of my brain is like, we should just make this foot blue, but I want to keep it consistent with everything else. So, okay. All right. So now we've recolored these people. Before I get into actually doing it, let's try to re-import this before I get into the furniture. I think we should just try to get the people working. And that's probably what I'm going to spend the next hour on is we'll just get the people working, and then tomorrow we can look into getting the furniture done. So I'm going to save this out, and we're going to break this right now. So if you're just tuning in, this is what we built yesterday, which is just a bunch of little Nintendo style sprites running in place. And we've cleaned up Pixel Vision 8's Sprite PNG sheet, and we're going to create a more optimized sprite sheet. Because right now, the sprites are taking up 2 pages of memory, which is a lot of memory. At least for a Nintendo, I'm using air quotes, you can't really see it, for a Nintendo style game. So what we're going to do is we're going to look into how to optimize this and get the most space in memory, because the tile map stuff for the backgrounds is probably going to use up the rest. I would like to have like 2 full pages of memory for the background stuff, which is I'm hoping going to be a lot more detailed. So let's the first thing we're going to do is let's export this, and I've already gone ahead and I've cut these all up into slices, and we're going to save this out, and we're going to go into the Sprite Builder right here. We're going to select all user slices, and we're going to output each one of these larger sprites. And I'll sort of show you what I'm doing so we can talk through it. And this is a tool that's built into Pixel Vision 8 Pro. This is called the Sprite Builder. So historically, when you're building Nintendo sprites, what happens is that each one of these sprites is made up of an 8x8 sprite, right? So if you wanted to have a larger sprite, if you wanted to have a larger sprite, what you'd have to do is go through each ID and create like a table or an array of each sprite's ID. Now, we're cheating a little bit here. What we're using is a draw sprite block, which allows us to define the upper left-hand corner of the sprite area and give it a width and a height, and it'll just copy this directly out of memory. This isn't the most optimized way to do it. So what we're going to do is we're going to save out a new PNG file that's just called Sprites. Let me set this to PNG. Sprites, we'll hit save and hit OK. So DigiGameBoy is asking, what's the size of the sprite page? So the one I'm saving out is 256 by 256. When we let Pixel Vision 8 optimize it, as long as it's a normal, like less than, I don't know, like 10 or 2000 pixels by 2000 pixels, it shouldn't be too hard to, it doesn't really matter the shape of it. If you want to keep it closer to sprite memory, set it to like 128 wide, and then, you know, however many pages tall. So that's, that's how I was having it before. So right now, if I go back in and I re-import this, it's gonna be looking exactly the same. So that means that something didn't happen right. Let's take a look here real quick at what I did. So for some reason that didn't save out. Where did I save this to? Okay, I see. I saved it in the wrong folder. Let's save this now as Sprites PNG. We'll save this here, and we're going to replace the Sprite folder in the sandbox. If we hit refresh, you'll see all the Sprite stuff is sort of mixed up. And I'm already starting to see some errors where magenta is showing through in the hair because it's not... Oh, actually, it's interesting. I wonder why it's picking up that magenta pink. It must be remapping to something. All right, so we'll take a look at that next. But what's going on now is we need to figure out... well, we need to tell it to optimize the sprites because these empty sprites are just wasted memory. So if we go back into our I have Atom opened, and I have it opened into the sandbox folder. So in Pixel Vision 8, sandbox folder in the workspace is where you work on the game. What we're going to do is we're going to turn off unique, and we're going to set this to, well, we're going to actually turn unique on, and we're going to set it to true. So let's come back here and we refresh this, and now you'll see all the sprites have now been compressed and are now taking up a single page. In fact, we have a little bit of extra space. This is including the furniture too. The font isn't coming in until the final row, so we do have a little bit of extra space for some stuff. So now what we need to do is go through and just sort of figure out what's going on with the color mapping. And I believe the reason the color mapping is off is because I haven't updated these colors yet. So I'm gonna copy over this palette that we created here. I'm going to go over to the colors PNG, and I'm going to replace these palettes that we created earlier with a new palette. And we're going to, I'm going to merge these two together, whoops, and save it out. So what we're going to see, and this is what makes working with palettes sort of difficult, is that right away, you'll see all the colors have been fixed, right? We're seeing that the sprites do appear to have color everywhere, but like things like the zombie, they don't look exactly like they're supposed to, and that's because we need to change the offset. So in this case, if we set the offset to 16, you'll see that we've moved every single color. So if this color was 0, we've added 16 to it. If this color was 1, we've added 16 to it, and we've shifted all the colors over by 16 colors, and this gives us our palette swap. So now we have the green for the zombie, and you'll see the orange is filling in nicely. We still have this little bit of magenta coming through, and that's the background transparency. If we were to turn this layer on, we would see whatever the default background color is, which is whatever, it's 0, so it's the pink. And that's more evident in like something like this. So if you wanted to test out what the background color would look like through the sprite, you could turn on and off the transparent mode, and everything else is sort of matching up. So it looks like our furniture is a little off. I think I just have to fix the colors. Let's do that real quick. So we were talking about this earlier. Depending on where you get the artwork from, you might have to just sort of redo the color spacing in the artwork. So what we'll do is let's take this off of mask mode, and I'll show you. Oh, that was a cool effect. Look, we got shadows for our characters. What we're going to do is I'm going to go through this blue here. Whoops. I'm going to select this blue, and I'm going to try to find a color that is similar to... actually, I can just do this here. I don't need this here. We're going to find a light blue that is similar on the Nintendo scale, which I just found. We'll do this gray. So it could be either one of these grays. I think this gray is a little bit darker. I don't think there really is a dark gray like this here. So we're gonna have to get that. There, we'll use this light gray here. This black should be the same, so I'm not worried about that. So blue. So okay. So what I was doing, why I copied over the Nest palette here is I'm gonna merge these. Whoops, I'm gonna lose. If I do it that way, I'll lose. We'll merge this layer in, and now when I select the colors, we should see that the color is being highlighted here in the palette. There are other ways of doing this. This is by far not the most optimized way of doing it, but it's just for time's sake and to make this sort of visual without having to go into like a whole bunch of different art programs. This is what I'm doing. So let's go through and let's fix this color, these colors as well. Whoops. That's a little too orange. I don't know if there's a good, it might just be a little too orange. Here, maybe this tan. Well, we can always fix this later in the palette. It's one of the things I was going to actually ask Evie if he could do is just create some good palettes for this stuff. Maybe he'll be better at it than me. I'm just trying to find a color that's close enough to this. All right, well, we're going to do this for right now. We're going to re-palletize them anyways, but I just want to make sure that the colors, a big part of what I'm trying to check is that the colors all match up and that we have the right number of colors per sprite. Again, like if you don't even want to do this stuff, if you don't even want to do the palette stuff, just make your sprites exactly the same colors as whatever's in your colors PNG, and you don't have to deal with all this palette stuff. The Nintendo is just a very unforgiving system. So if you don't get these palettes 100% correct, it's really difficult to work with. Let's see, this blue was already matched. All I need, I think, is this darker purplish blue, which could be this. There we go. So that's there, the black's there, the blue's there, and the brown should be there. All right. So you'll see, okay, so now we've remapped the colors, we've cleaned them up. Let's save our work, and I'm gonna save out the sprites PNG again. Let's do PNG, save, replace. Yes, large file size, whatever, it doesn't really matter. And I am recording this. I will go through, once I do the next release of Pixel Vision 8, I'm going to go through and start doing some videos that are specifically towards how to use these tools. There's a huge amount of stuff that I need to document. So as you can see, I remapped the colors. I basically got them optimized now to the Nest palette, and all the missing sprites or stuff that that we didn't need has been removed automatically by the editor. So all right, so that being said, we now have a completely optimized palette set. What I want to do is I'm going to re-export each of these sprites though into our Sprite Builder folder, and I'll show you guys how the Sprite Builder works. And then we'll see if we have some time to fix the animations before the end of the stream. So we'll refresh this now, and I was talking about the Sprite Builder. Basically, having to create each one of these sprites in a draw call by hand by knowing each sprite ID is going to be sort of a pain in the butt. So what we're going to do is we're going to output a image of what the sprite should be, and we're going to let Pixel Vision 8 automatically look at that image, figure out the sprite IDs for us, and create a Lua file that'll have tables that have all of these sprite IDs by the sprite file's name. So what I've done here is I've created a folder in my project called Sprite Builder, and in it you'll see here are all the different sprites, right? And it's very important to note that they have to be at the exact dimensions of the sprite. So I said that poorly, but in this case, like, you can't just have like arbitrary sized sprites in here. They have to fit within the grid. So they have to be divisible by 8 in order for them to work, because it literally goes through and cuts it up into 8 by 8 slices and tries to figure out which sprite is where in memory in order to make this work. So once we have this folder, this Sprite Builder folder with all these sprites, all we need to do now is go into the Sprite tool and click Build, and it's going to build out the file. You see it's really quick, and it created a new SB Sprites Lua file for us. Now, if we open this up, you'll see here are all the sprites. This is the furniture couch, the large dresser, the girl idol, and it's gone through and it's basically created everything we need. Now, I've noticed one thing here that's going to bother me. I like to remove the spacing between them and just make it as one straight string. So I was using underscores in these sprites. So bear with me for a minute. I just want to go through and fix the names here and make all this stuff. Whoops! Oh no! Where did everything go? Some weird Mac keyboard command that I don't know. I'm just going to go through and rename all these, just because I want this to be consistent. Because when we start implementing it, it's just going to be a lot easier to do it this way. And my OCD is sort of like, yeah, OCD. So while I do this, if you guys have any questions or stuff about what I'm doing, feel free to ask. This should take me a few minutes. Whoops. Okay, that's a cool new keyboard shortcut. I wish there was a way that I could actually like bulk do this. But oh well. So part of what the Sprite Builder does is it actually will remove it'll remove dashes, since that's not a valid variable name, and it'll just God, I gotta stop doing that. And it'll just keep it will remove the dashes and make it just a single string. So it tries to make valid variable names. I don't know. Oh, my stomach is growling too. That's fun. I'm probably gonna rename this stuff, take a quick break, and then I didn't get it. You exported each frame. Okay, so I'll sort of try to walk through it again. Yeah, so what I did was what the Sprite Builder does is it looks through a folder of sprites, a folder of PNGs, and it tries to oops, I keep doing that, which is annoying. It goes through sprite memory. So let's take like this one image that I'm clicking on here, right? If this is a single image, it'll load that up, look through each of the 8x8 tiles inside of that image, and see if a tile is sitting in memory, and give you back a Lua table with the ID of where that sprite was sitting in memory. So instead of you going by hand in the Sprite tool and just creating a table with each sprite ID, the Sprite Builder does it for you automatically, and it does it by whatever PNG files you include in the Sprite Builder folder. So you could have multiple images. You could do your entire, you could do all your sprites, your background tiles, whatever you want that you want to have access to and to draw as a gigantic sprite or something. You can put into the Sprite Builder folder, as long as the image that you use has the same sprites in memory. So to clarify, the reason why I create this one sprite PNG file and then I cut out from that is that I ensure that the sprites that I'm cutting out are going to match up 100% to the same ones in memory. Does that sort of clear it up? I have to come up with a better way of explaining it. It's not importing the artwork. It's just simply looking at any of the PNG files in that folder and making sure, or looking through them and seeing if they match up to what's in memory, and then giving you back all the matches. So think of it like a visual-based search tool. Yeah, it's just a way of automating it. It's there is no way. The only way you can import sprites into Pixel Vision 8 is through the Sprite PNG file, or you could just load it up into Lua and then just write them directly into memory. So that's possible too. So if you wanted to write your own parsing tool, you could do that as well. This is documented pretty well, I believe, in the in Pixel Vision 8's documentation. So let's see here. So I'm gonna do this real quick. I'm gonna I'm gonna re-export all these images, rebuild the Sprite Builder file, and then I'm gonna take a quick, like 5-minute break. I just gotta go snack on something, because my stomach is growling. So unless you want to hear my stomach growling for the next 30 minutes, and then what we'll do is we'll take the Sprite Builder output. We're gonna rebuild the animations using the Sprite Builder stuff, which is a lot easier. And the reason why we use the Sprite Builder is going to be a lot more apparent, but at a high level, let me just export these. And now if we go back in here, we'll refresh this and let's rebuild. And now if we look at this file, we'll see that there's no underscores and that all the naming is consistent. So the reason why using the Sprite Builder stuff is important is because once we've generated out this variable, did I spell zombie wrong? Ah, come on, Jesse. Yesterday was like a bad day. Like my brain just like didn't want to spell anything correctly, which is sort of like on par, but yesterday was like seriously bad. No. All right, let's fix all my typos and all my stupid stuff. Yeah, if you DigiGameBoy, I do save the streams to YouTube and to my my Twitch page. So feel free if you miss anything, you can always go back and watch it later. All right, so let's export these again, save it, and redo the Sprite Builder. All right, so now zombie should be spelled correctly. Okay, so one thing I was saying was the advantage of using this is that now whenever we go to draw something, we can just say, okay, draw the zombie running 5. Here are all the sprite IDs. And over time, as your graphics change or the positions of these IDs change in memory, all you need to do is rebuild the the SB sprites file. And since the variable names will stay the same, it doesn't really matter where the IDs are, and you can sort of decouple the code and make the code a little cleaner. Let's all right, we're gonna use this opportunity to take a quick 5-minute break. And I'm gonna come back at what is it? It's 10:50 EST. So I'll be back at 10:50 EST. I think it's 10:44 right now. And then when I come back, we're going to redo the animations and we'll use Sprite Builder, and then I got to call it a day on the stream. So I shall return. Okay, I'm back. Let's see. Hopefully we didn't lose everyone. Let me just do a quick check to make sure my sound is working. Testing, testing. Hey, look at that. My computer didn't crash or do anything stupid. So, all right. Now that I'm back, what we're going to talk about real quick is we're going to redo the animation logic in the little game that we built yesterday. And what we were doing this morning was taking our sprites, changing them so that they could be palletized. As you can see, all the sprites now are sharing similar colors, and we can create different palettes for them. We didn't do that for the furniture yet. We'll do that another day. And then, in addition to exporting this one image as the sprite PNG that Pixel Vision 8 is going to load in Photoshop, we've created little slices for each one of these sprite animations. And we're using Pixel Vision 8's Sprite Builder tool to look through a folder of these exported PNGs and give us back a Lua file that has tables for each of the sprites and the IDs that make them up. So this is sort of the way that we work with larger sprites in Pixel Vision 8, because just like in any 8-bit game console, all sprites are made up of 8x8 tiles. So if we were to go into here and try to piece this together by hand, it would be a lot of work. So since I'll just walk you through the process of what I did before. After I sliced up all these things and gave them names, I just simply go to the Save for Web tool, hit Save, and I have a folder in my workspace in the sandbox folder, which is where our game is, called Sprite Builder. I export each of these sprite files. And then if we look in the Finder, you'll see each one of these. So this is what I want the sprite to look like in the game. This is the exact dimensions. It's important to remember that they have to match up to the sprite grids. They have to be in divisible by 8 because the sprite is 8x8 pixels. So as long as they are, so you see there's a lot of like empty space around this character, but I still filled it out to the exact dimensions of how many sprites. So it's 3 sprites across and 4 sprites down. And now that we have this folder, all we do is in Pixel Vision 8, we just click the builder, and it will create a new Lua file for us. So inside of our project, I'm just going to close out that real quick, and look at our project. So I have the workspace folder open up in Atom, and this is sort of the preferred external text editor of choice. So what we're going to do is, before we jump into this, let's just go through. I'm going to close out this Pomodoro. Let's see here. So we've optimized the artwork. We've created palettes. We haven't gotten them working. We've generated out a Sprite Builder file, so we can check that off and we can submit it. And now there's one other thing I just want to do, because it's getting like really lonely in this vacuum. I just need to put some music on that I can hear, that you guys won't be able to hear. Hopefully you guys won't be able to hear, because it's driving me nuts hearing myself talk. So, okay. So what we're going to do now is Pixel Vision 8 has created this sprite, this SB Sprites Lua file. And we'll close this out. We'll take a look at this. This is all of the sprites that make up each of the PNG files we put in the Sprite Builder folder. So let's take a look at this real quick and how this works. So let's look at our furniture couch, right? If we look at the couch, you'll see that furniture couch here, it's a width of 4 sprites, and its sprite IDs are -1, 223, 224, -1, -1, -1. So something, it looks like there was an error here where it wasn't really finding that sprite. Maybe there's something where it's not matching up the colors correctly. So where we see -1, that means it can't find the sprite. If we look at the Girl Idol 1, hopefully we'll have a little bit better luck with that. So Girl Idol 1, it's a width of 3 sprites. Its sprite IDs are 0, 104, 0, 109, blah, 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 blah. And there should be a -1 and a -1 on either side. Now, we can match this up with the game creator. So if we came into the game creator here and we looked at sprite 104, we would see it's the top of a head. If we did 110, we'll see it's the girl's face. So that looks a little bit more promising. And a lot of this is a little bit of trial and error, making sure that you have everything set up correctly. But the good thing about the Sprite Builder is that once we generate this file, if we just try to, if we set everything to this variable, as we update the sprites and change the sprites IDs, we don't really need to know about any of this information. We just need to know the name of the sprite, and it allows us to decouple some of the hard-coded stuff we would have to do before. So as an example, when we created our guy entity, we actually had to hard code a few of the IDs for the sprites. Now we're going to need to restructure this a little bit, and what we're going to do is change this code on the animation side so that it works a little bit easier with the Sprite Builder format. So the first thing we're going to do is when we go to create our guy entity, let's go ahead and I'm just trying to think of how I want to do this. We're gonna give it a name. So we're gonna call this sprite name, and we're gonna use the well, actually, you know what? We don't want to use sprite name. That would be a problem. What we're gonna do is I'm just trying to think through how we're gonna do this. We're gonna put the here's what we're gonna do. Before, we were using a method here called draw sprite block. Draw sprite block required the top left-hand corner of the sprite, and then it went through the width and the height. So 3 sprites over, 4 sprites down, and just copied that directly from memory. If we, my furniture, so I couldn't spell furniture earlier today. If we go in here and we rerun this, you'll see that all of the animation is sort of messed up because it's just copying stuff from memory, but everything is compressed now. So it's not going to be in the same positions. So let's go through here, and we're going to try to rename this. And what we'll do is we're going to call this, where is guy idle 1? We'll do guy idle 1, and we're going to do sprite IDs. And now we can replace this with idle 2, idle 3, and idle 4. And I'm going to save this. And while we're testing it out, let's go ahead and disable the other 2 draw calls. And we're going to now change this to draw sprites. And draw sprites is going to be a little bit different. First off, we're going to need the sprite IDs, and we're going to make a new variable for sprite IDs. In fact, what we can do is let's just reference the actual sprite object, or the sprite table that we created. So we're going to get all the sprite IDs from each one of these. We're going to use the width, but we don't need the height anymore. This draw sprites allows you to simply say, here's a collection of sprites, here's how wide it is, and draw it down, and it'll automatically keep filling in the rows until it runs out of sprites. And everything else should be exactly the same. So what we need to do in the animation area is we need to change this sprite ID to a sprite IDs, which is just going to be a table. We're going to set this to nil for right now. And let's go ahead and find where we update sprite ID, which is actually right here. So let's change this to sprite IDs. And what we're going to do is we're going to look for the target frame, and we're going to do .sprite IDs. And this is a little bit convoluted, but in essence, what we're looking for is we're looking for the target object's frames table. We're going to look for the current state so we can pick which state it is. So if we look back here and we take a look, the first state 1 is going to be the idle animation. Then inside of the state is going to be a frame. This is the ID. So in that table of state animations, which table we're going to use. And then since each one of those items in the table references a Sprite Builder or a Sprite Builder sprites object, we're just going to call sprite IDs on it and get a return of the sprites. So if everything is set up correctly and I hit save, we should be able to just run this now. Oh, and we got a null reference error. So this null reference error is because we are not importing the actual sprites. So what we need to do is call load script, and we're going to call SB sprites. And this will load in the sprites that we've generated before we create the entity class. That's sort of important. So let's go here and let's refresh the game. And we're still getting a null reference error, huh? I wonder what that is. Let's just backtrack for a second and let's just disable all this stuff and just see if we can get this running. All right, so the first thing I want to do is let's just animate everything. And let's see if we created a problem here with this animation. Because I have a feeling that when we try to draw it for the first frame, it's set to null. And because it's set to null, there's nothing that we can draw. So let's actually do this. So if I reintroduce this draw call, it's going to throw the null error. Let's go ahead and set this draw sprite IDs. And, well, this is never going to work. So we should have a race condition here. What we want to do is I'm just trying to think real quick how we can solve this. There's lots of ways we can do it. One of which is we can just test to see if this isn't null, which is probably the safer thing. If this does not equal null or nil, then end. All right, let's see if this fixes the error. There we go. All right, so as you can see, we're now using draw sprites to draw this, but it looks like some of the frames of animation have problems in it. So let's take a look at our guy idle and see why we're getting negative values. So this should work correctly. Famous last words, right? Guy idle 1, 2, 3, and 4. So I'm not sure why this is happening. The only thing I could think of is that maybe it's running out of sprites, but that shouldn't happen. Let's just for a sanity check, let's just try to draw this and see what happens. So we're gonna just draw this by hand. We're gonna call draw sprites. We'll call it sprite IDs 8. The width is 3. False. False. We don't want to flip it. Our draw mode is going to be sprites. And our color offset is going to be 0. And this is going to be false, false, and we're not going to pass in a custom bounds rect. So we'll hit save, and let's just try to refresh this real quick. All right, so that one is missing something. Let's look at 2. Three. And 4. All right, so let's take a look and try to figure out why this is happening. So what we want to do is we're just going to go through and try to debug these sprites. So the head, let's look back at Photoshop and take a look at our head. We want to see what this body area is. So it looks like this center one here. So let's see. This is 1, 2, 3, 4, 5, 6, 7, 8. So the 8th ID is saying it's negative or is not displaying anything. So this is 1, 2, 3, 4, 5, 6, 7, 8. Interesting. All right, so here's my theory on what's going on. We may have too many colors in this area right here. And this is where the Nintendo colors per sprite is going to be very picky. So what's actually happening is this orange is pushing us over the color limit. I'm going to go in and I've been actually thinking about this for a while. I think I'm going to go and I'm going to increase the sprites per color because it isn't really working the way that Nintendo would work. I set the sprites per color to 3, but it really should be, it's technically 4. One of them should be left empty as transparent. So let's see if this fixes the animation. Oh, I gotta redo the Sprite Builder. Hold on a second. Let's redo the Sprite Builder and rerun it. There we go. All right, so the problem that we're getting to is that there are too many colors in the center area. And this is something I introduced when I did the palette stuff. I think for right now we're just going to leave it as is. It's really not worth the effort. And this is sort of what I've been trying to. This is the balance that I've been trying to do with Pixel Vision 8 is getting it to where, while you can keep this exactly like a Nintendo and keep the specs similar to Nintendo, a lot of times it's just too difficult to work with. So really, Pixel Vision 8 is about having fun building 8-bit games. So if you're struggling with some of these older restraints, then just ignore them. So now if we go back and we rerun this, we'll see that the animation works like it was supposed to. All right, so let's go back through and let's do the other animations and let's get them working. So what we're going to do is we'll go to our sprites here and we're just going to replace all these values with what we need here. So this was 2 and 3, and then we'll just do the running. I'm going to have to sit down and really rethink how to do the colors per sprite because it doesn't match up 100%. Although, because I'm not taking into account transparency. So I'm pretty sure that Nintendo, if you really think about it, only supported 3 colors per sprite. So I might have to go back and fix it. Even background tiles still could have transparency in them, and that was the 4th color. So, all right, we'll deal with that in a minute. So what I'm going to do here is I'm just going to I want to do a find and replace for the word guy with girl in a selection, which should just be this one selection. And let's replace all. Why didn't it why is it not finding this? "12 results, replace all." There we go. All right, and then we'll do this for the zombie. We just needed the zombie running. So one of the problems we're just running into is that because we're using a helper function to draw a lot of sprites at once, we're applying the color offset to all those sprites, and we don't have very granular control. So it's sort of complicated to explain, but the long story short is that on the Nintendo, you would just basically draw each sprite and give it a palette. And since we don't have that granular control right now, it's a little bit problematic in the API. Let's refresh this and see if we get these guys to run. Code 88. Right, we need to change this, and let's copy this. So we just want to make sure that before we go to draw any sprite, that the sprite data actually exists. And this is more to protect you, especially when you're working with the Sprite Builder. If something happens where all of a sudden the sprites you were relying on no longer exist, you just want to make sure that you're not accidentally drawing something. It's easier to replace something that's missing, if you notice it's missing, than if it's throwing an error and sort of crashing your game. Let's see here. So let's restart. Oh, and we're still getting a runtime error of 90. Oh yeah, right. We need to do draw sprites, and let's get rid of the height. And rerun this. There we go. Okay, cool. We've now correctly fixed all the sprites. The girl is on her own palette, and our zombie is a little bit off. What I want to do now is let's try to do... What do we want to do here? Let's see if we can fix the colors per sprite, and then we'll end it there. I gotta head out of here in a minute or anyways. So let's go back into data. We're gonna change the colors per sprite to 3. And oh, I need to rebuild this. All right, so what's happening is that we're missing some of these colors, and I think what we're gonna have to do is if we look at the guy, he basically shares the same color hair as the same color pants, which gets us around that issue. I mean, one way we could do it is we could also make him have the same color shoes, but then I guess you lose that depth. And these are the trade-offs, right? So let's see if we can just fix this guy here. So I'm gonna save. Ugh, my voice cracked. That's weird. I'm gonna save this as Sprites v1 for CPS. And then we're going to reduce this back down to 3 CPS, which is colors per sprite. So let's select this guy. We're going to copy and paste him and then put him back in place. We'll hide the old one. And now what we're looking to do is we're going to take this yellow. That's strange. Why is it? Oh, I see. Oh, look, because I highlighted the layer underneath. It's highlighting them together. So we're going to match... Whoops, I don't want to do that. We're going to go to this layer here. And we're going to take all the yellow and we're going to match it to the... what comes first on this color map? That yellow comes first. So, all right, so what we're going to do is... we're actually going to take this and we're going to map it to yellow. Now let's we're going to do this in several ways. First off, we got to update all of our individual sprite layers. So let's enable this, and actually we're going to do it this way. This is sprites for CPS, sprites 3 CPS. All right, so the other thing I wanted to fix was I feel like his center had too many colors, but It was right here. This one here is, this one and this one have too many colors. Basically the orange, blue, this purple and red are just too many colors. So what we need to do is, let's take a look at, I wonder how that got rendered before. That's interesting. I have a feeling like there is I have a feeling like there's a bug in the sprite parser. Let me file a bug real quick. That sprite sprite import ignored 3 CPS setting for sprites, but Sprite Builder used the limitation, so wasn't able to match up correctly. All right, one of the things I've been doing in this last build is just making sure that that the import stuff, that each of the importers are using the same sort of logic for parsing the sprites. So I just want to make sure that both of them are using the same underlying logic. This way you don't get these weird issues where the Sprite Builder works, but the Sprite importer doesn't. All right, so now let's go ahead and let's re-export these, save them all. And then I need to save a new Sprite PNG. So now what's going to happen is that for the guy, his pants and his hair are going to match up. So we'll go into here. And oh, I need to redo the Sprite Builder. Now that we've redone that. Okay, those are the 3 steps we need to do. Funny, we're still not getting... Oh, that's why, because this is too many colors still. Man, that Nintendo limitation is something else. So this one sprite here, which is the center of his body, is actually it's using too many colors. 2, 3, 4. What's interesting is that it's 1, 2, 3, 4. All right, so there is a bug here. I'm gonna take a screenshot of this real quick and add this to the bug, because documents, something's wrong. Workspace, sandbox. Actually, I'm looking for screenshots here. Whoa, Crazy Land. Well, that screenshot's wrong. Something got corrupted. That's strange. Let me look at that again. Okay. Can someone explain to me why this looks right here, but when I open up in Photoshop, the colors are all wrong? It's corrupted somehow. All right. Do I have a new bug in the... I'm going to save this real quick. Let's quit this out. I'm going to quit out of Photoshop and just restart it. Oh, that was weird. Photoshop was completely freaking out. I was like, wow, that's a weird bug. I've never seen anything like that. All right. I just want to add this into the bug so I know what I'm looking for. Sprite has too many colors. All right, update the comment, and there we go. So now I can at least go back and reference this when I'm trying to fix the bug. So okay, I think I'm going to end it here. This is sort of a natural break. What we're going to do is so what we'll do tomorrow is we'll go back in. We're going to try to fix the we try to fix these sprite colors. This is a tough one. I mean, this is actually I wanted to go back and just I want to take a look at this real quick. What I was trying to think of is can I I'm an idiot. I saved over what I was doing. Whatever. All right. Oh no, wait. This is for CPS. All right. Maybe I didn't save over it. There we go. One thing I was thinking we could do is when the player is standing, since his legs are the same. But this 1, 2, 3, 4. Yeah. All right. What's just going to wind up happening, which is sort of a shame, is this color is going to have to match up to this green. So he's going to have the same. They're going to have the same color shoes. I mean, this is one of the defining characteristics, though, of the Nintendo is how limited the colors were per sprite. So in trying to replicate that, it's just going to take a lot of extra effort to get these sprites to be working according to a Nintendo's limitation. Let's see if we can just get that idle animation working again. We're going to export these here. Well, actually, 1, 2, 3. Yeah, that's it. It looks like I exported these to the wrong folder. Let me just do this again to the Sprite Builder folder. Save this, and then we're gonna go. Whoops, we're gonna go into the folder, and I want to remove all these files that I accidentally added here. Where the kind PNG. Let's make sure we don't delete. Whoops. Let's make sure we don't delete our sprites or our font. And delete this. And now, if we reload this, what was that? 41. Cool. Now nothing works. Oh, whoops, I deleted the colors. Brain's not working today. Gets to that time of the day where I'm just like, it's lunchtime and I can't focus. All right, let's do this. What was that, 41? I bet you all this stuff got shifted around. 1, 2, 3, 4. Yeah, this is... Man, this is going to be tough. We're going to have to really go through and cut down on colors here. I don't know if Evie's going to be happy with it. So if we redid the Sprite Builder and rerun it, I'm still getting that problem. Okay, tomorrow we'll go through and we'll get these sprites better aligned with the NES color limitations, and we'll figure out what we're going to lose. I'll also have to go back through and fix this bug where this is 1, 2, these are 3 colors. This is fine, but right here, having this hand here, this is not going to work. And because the hand is, I mean, there's a lot of ways we could fix this. We could do a sprite on top of it. Like, there are some things I could do to make this work. It's, you know, this is the challenge of working with Nintendo-style sprites. So anyways, thanks everyone for watching. I'm going to end the stream, and let's close out this last Pomodoro. We basically are still working on the color palettes and trying to get everything cleaned up. And thanks for watching, and I'll see you guys tomorrow when we look into how to actually get this stuff to be optimized. Before I do that, I'm going to revert this back. Excuse me, see if yeah, this is going to be interesting. We're going to have to figure this out. So we'll save this and we'll deal with that tomorrow. All right, Thanks, everyone. See you tomorrow at around 9:30 Eastern.